and click finish. Now check the run simulation, calculate. Okay, plot, check the tank 1 production history or tank pressure like this. Now we compare with the simulation, tank pressure, right? Perfectly match. Yeah, we can still make the match better, but I think it's not very necessary because from here we can see that it is almost matched. Okay, and then now we can generate the average oil rate like this. And if we want to show the recovery factor, then it is like this. Okay, so production from 1990 to 2003, we still can only reach recovery factor of 7.3966 or 7.4%. Okay. Yeah, you can also plot others. If you want to show the average oil rate, average gas rate, average water rate, there is no water. Okay. And then the reservoir voidage. And then what can we show from transmissibility? Yeah, this is the flow transmissibility. So 0 previously, because still the pressure threshold hasn't been reached. So there is no flow from tank 2 to tank 1. That's why it's 0. But after that, there is flow. That's why here we have negative value, showing the support from tank 2 to tank 1. Okay, previously 0. Previously there is no flow. That's what we can plot in the transmissibility. Very interesting. Okay, click done. And we will not do prediction here. So the main thing that we learned in this video is how to simulate the transmissibility or connectivity between two reservoirs. So we can recap. In this video, we construct a reservoir model. It has production history, and we know from the production history there is something weird about this, because here we have fast reservoir pressure drop, but after that the pressure drop becomes slower. So we ask ourselves, what happened? Is there any aquifer, or is there another reservoir that is supporting our reservoir or our reservoir? We know for sure there is no aquifer based on log, based on seismic, based on core, there is no log, there is no aquifer. So the only reason is that we have pressure support coming from the outside of our reservoir. So we analyze and we think that there is another reservoir that is connected somehow with our tank 1. And for example, there is leaky fault or there is connection between tank 1 and another reservoir. So we create transmissibility to represent the connection between tank 1 and this tank 2. Okay, and we know that we still haven't produced any fluid from tank 2. So we create the model for tank 2, but there is no production history. And then we connect tank 1 connected with tank 2 through this transmissibility, and we perform history matching, okay, in the tank 1, and we do regression to get the correct oil in place of tank 2 and transmissibility of tank 2, or I'm sorry, or transmissibility between two reservoirs. And then we obtain perfect match and we are satisfied. Okay, so that's the whole story. I hope you understand and see you again in the next learning for this reservoir simulation. Thank you.